ladies and germs? My name's Troy Transformation. I'm here to teach you about some reflections today. Nothing I like more than my own reflection. What?
First thing we're talking about is a transformation. That's a change in the position of a geometric figure. So down here we have triangle ABC and triangle A prime, B prime, C prime. The little apostrophe after each of the letters. We refer to that as a prime. Now, what does that mean? Well, it means that this triangle, ABC, was our starting triangle. And this A prime, B prime, C prime is how the triangle ended up after our original triangle underwent some type of transformation. In this case, it was slid. Over here, we have triangle XYZ and triangle X prime, Y prime, Z prime. So again, this is our starting triangle, and then this is the triangle that ends up after this original triangle, our starting triangle, underwent some type of transformation. And we'll get into the different types of transformations later. Now, the pre-image would be the original figure. So that's our starting figure. Like when we saw here, triangle ABC, that's our pre-image, the original starting figure. The image then would be the resulting figure. That's what happens after you transform your pre-image. So some type of transformation happens to your pre-image, triangle ABC, and we end up with the image, triangle A prime, B prime, C prime. Now, a congruence transformation, or isometry, is a transformation in which the pre-image and image are congruent. So here there are three types of isometries, or congruence transformations, that we're going to work through this chapter. We have reflections, translations, and rotations. A reflection is where you take the pre-image and you reflect or flip each point over a given line, which we call the line of reflection. A translation is where you take your pre-image and you slide each of the points a certain distance along a given vector. A rotation is where you take your pre-image and you rotate each point around a given point. In this case, it would be the origin. Now, a reflection or a flip is an isometry in which a figure and its image have opposite orientations. So here you can see we have our original figure, our pre-image, triangle ABC, and then our image, triangle A prime, B prime, C prime, after our pre-image was reflected over the x-axis, or sometimes they say reflected in the x-axis. And that just means that each point is flipped over the x-axis, meaning that each point is the same distance from the x-axis that it is on the opposite side. So point C is 2 units away from the x-axis. That means C prime is also 2 units away from the x-axis, just on the opposite side of the x-axis. Point B is 4 units away from the x-axis. Therefore, B prime is 4 units away from the x-axis on the other side. A, 1 unit away from the x-axis. A prime, 1 unit away from the x-axis on the opposite side. That's a reflection. Now let's talk about reflecting a figure over a given line. So this is where you reflect a given figure over a line and it's not in the coordinate plane. In order to reflect this triangle ABC over the line N, or in the line N, the first thing we're going to do, we want to draw a line through each vertex that is perpendicular to line N. So what I'm going to do is I'm going to take a protractor and I'm going to line it up with the bottom on line N. And I'm going to make the 90-degree line go through each vertex, each point, and draw a line that goes through line N and on the other side. So let me show you how this works. I take a protractor, I line up the 90-degree line so that it goes through point B, and then I draw a line going through that 90-degree line and continuing on the other side. So it looks something like this. We have created a line that goes through our vertex and is perpendicular to our line of reflection. Do the same thing for point C. I get my protractor, I line up the bottom with our line of reflection, I make sure the 90-degree line goes through my vertex, and I want to draw a line that traces that 90-degree line and continues it on the other side. Now I have a line that is perpendicular to my line of reflection and goes through my vertex. Same thing with point A. Line up the bottom of my protractor with the line of reflection, make sure my 90-degree line goes through my vertex at point A, and I create a line that traces that 90-degree line and continues it on the other side. So I now have all 3 lines that are perpendicular to our line of reflection and go through each of our vertices. Sweet, we just completed the hardest step. Now all that's left, the easy stuff. So step 2, we're going to measure the distance from one vertex to line N. So let's take the distance from point A to line N. We need to find that distance. So let's say it's 2 inches when we measure that distance. The whole reason we continued this line all the way through on the other side is in step 3, we're going to measure out that same distance, 2 inches, on the opposite side of line N and on that same perpendicular line that we drew. If this is 2 inches from point A to our line of reflection, then we take that 2 inches and on the other side, we put our point of reflection. Instead of A, it's going to be A prime over here. Then all we have to do is just repeat that for the other vertices. So these two vertices, we do the same thing. We measure the distance from point C to our line of reflection. It's 1/2 inch. We then take that distance, measure it out on the other side, and put our C prime, our reflection of point C, over line N, or in line N. Do the same thing for point B. We measure the distance from point B to our line of reflection and measure out that same distance on the opposite side of the line of reflection on our perpendicular line. We put B prime, and now all we have to do is just connect these dots. We have our image of triangle ABC after it's been reflected in the line N, or over the line N.
Oh, you better believe it's example time.
Okay, example 1, doing the same thing. First, I want you to copy the figure here, trapezoid DEFG, and line J. Then we are going to reflect this trapezoid over the given line of reflection, line J, or in the line of reflection. So how do we do that? Well, step 1, we want to draw a line through each vertex that is perpendicular to line J. So here's how you do this. You get your protractor. You line up the bottom of your protractor with the line of reflection, and then you make sure the 90-degree line goes through one of our points. We'll start with point E. So we line up the bottom of our protractor with the line of reflection. The 90-degree line is going through point E, or vertex E. We then trace that 90-degree line with our ruler. On our paper, we trace that through our vertex, through the line of reflection, and continue it on the other side of the line of reflection. We have then created a line that is perpendicular to line J and goes through point E. Let's do the same thing for point F. We put the bottom of our protractor on line J. Make sure the 90-degree line goes through point F. We trace that 90-degree line with a ruler through point F, through our line of reflection, line J, and continue it on the other side of the line. Next thing, doing the same thing with point D. We put the bottom of our protractor on line J, our line of reflection. We make sure the 90-degree line goes through or is in line with point D. We trace with our ruler on our 90-degree line through point D, through line J, and continue it on the other side of the line of reflection. Last but not least, we do the same thing for point G. Have the bottom of our protractor on line J. Make sure our 90-degree line goes through point G, and then we trace that 90-degree line through point G, through our line of reflection, and continue it on the other side with a ruler. Step 1 is done. Step 2, we can measure the distance from one vertex to line J. So this is the easy part. You just take out your ruler and you say, how far is point E from line J? Well, on this line, if we were to measure this distance, we see that it's 4 centimeters. So then you take your ruler, you measure out 4 centimeters on the opposite side of line J, but can keep it on that same perpendicular line, and you put the reflected point E on the other side, the image of point E on the other side, which we call E prime. Now do the same thing for every other point. So we take point F, measure the distance from point F to line J. We measure out that same distance on the opposite side of the line of reflection, and we put the image of point F after we have reflected it over line J, or in line J, and we call it F prime. Same thing with D. How far is D from the line of reflection? We measure that distance with the ruler. It's 8 centimeters. So you measure out 8 centimeters on the opposite side of the line of reflection. You put a point that would be the image of point D after it's been reflected over line J or in line J, and it's D prime. Last but not least, we take G. How far is G from the line of reflection? That's 2 centimeters. So we measure out 2 centimeters on the opposite side of the line of reflection. We put G prime because it's the image of point G after it's been reflected in line J, or over line J. All that's left now is to connect the dots, and we see that our image of trapezoid DEFG after it's been reflected over line J or in line J is this red trapezoid over here. Trapezoid D prime, E prime, F prime, G prime. So this is our pre-image, this is our image. Now let's talk about some reflection cheat codes. So there are several that I need you to remember. First, let's say I have a point. Point A is at 5, 2. It's over 5 on the x-axis, up 2 on the y-axis. If I wanted to reflect point A over the x-axis or in the x-axis, all that you have to do is take that ordered pair and make the y value the opposite of whatever it is. So if I want to reflect point A over the x-axis or in the x-axis, I just take 2 and make it the opposite, -2. So A prime, after I reflect it over the x-axis, would be at 5, -2. That's how you reflect something over the x-axis. Just change the y-coordinate to the opposite of whatever it is. If it was -2, you would make it +2. Now let's say I want to reflect point A over the y-axis. You would just, as you can imagine, make the x-coordinate the opposite of whatever it is. So if I want to reflect point A over the y-axis now, I'm going to take that x-coordinate and make the opposite of what it is. So instead of being 5, 2, it's going to be -5, 2. So I go over -5 on the x-axis, up 2 on the y-axis, and that is where A prime is after I reflect it over the y-axis. Last but not least, I want to show you how to reflect something over the line y equals x. And some of you are thinking, what is the line y equals x? Well, y equals x is just everywhere where y equals x. 1, 1, 2, 2, 3, 3, 4, 4. Or you can think about it in terms of slope-intercept form. It's a line with a slope of 1 and a y-intercept of 0. So it has a y-intercept of 0 and a slope of 1. Up 1 over 1, up 1 over 1. So if I want to reflect my point A over the line y equals x, I just flip the x-coordinate and the y-coordinate. So instead of being at 5, 2, if I reflect point A over the line y equals x, it's going to be at 2, 5. So I put A prime at 2, 5, and that's how you reflect over the line y equals x. Now example 2 says given points R, S, and T, draw a triangle RST and its reflection image in each line. So here are lines of reflection that we're going to take RST or reflect over. But first I need to graph triangle RST. So let's graph point R. It's at 1, 2. I go over 1 on the x-axis, up 2 on the y-axis, put a point, that's R. S is at 5, 2. I go over 5 on the x-axis, up 2 on the y-axis, put a point, that's point S. And then T is at 3, 5. I go over 3 on the x-axis, up 5 on the y-axis, put my point T. There is my triangle RST. Next, I'm going to draw its reflection image in the x-axis. So where's the x-axis? That's right here. And how do I reflect each point over the x-axis? Well, remember, you just take the y-coordinate and make it the opposite of whatever it is. So instead of R being at 1, 2, R prime is going to be at 1, -2. Instead of S being at 5, 2, S prime is going to be at 5, -2. And instead of T being at 3, 5, T prime is going to be at 3, -5. And there is my triangle R prime, S prime, T prime after I've reflected triangle RST over the x-axis. Now a little helpful hint, if you forget this cheat code, remember R and R prime are going to be the same distance from our line of reflection. So if R is 2 units from the line of reflection, R prime, you just count 2 units over here, and there's R prime. If S is 2 units from our line of reflection, S prime is just going to be 2 units on the other side. And then if T is 5 units from our line of reflection, T prime is going to be 5 units on the other side. So in case you forget this, you can always just count. Now let's look at the y-axis. If I were to reflect triangle RST over the y-axis this time, I just need to take each x-coordinate and make it the opposite of whatever it is. So instead of R being at 1, 2, R prime is going to be at -1, 2. Instead of S being at 5, 2, S prime is going to be at -5, 2. And then instead of T being at 3, 5, T prime is going to be at -3, 5. And there is triangle R prime, S prime, T prime after we've reflected triangle RST over the y-axis. Remember, since this is a vertical line, just like a horizontal line, you could just count. How far is point R from the line of reflection? 1 unit. Therefore, R prime is going to be 1 unit on the other side. How far is S from our line of reflection? That's 5 units. Therefore, S prime is going to be 5 units on the other side. Since T is 1, 2, 3 units from our line of reflection, T prime is going to be 1, 2, 3 units on the opposite side. Next, we're going to reflect triangle RST in the line or over the line y equals 5. Now, where is the line y equals 5? Well, remember, y equals a number. That's a horizontal line. So we go to the y-axis at y equals 5, and we're going to draw a horizontal line everywhere where y is equal to 5. That's what this line indicates. Again, we have a horizontal line. So anytime you have horizontal lines or vertical lines, you can just count. You don't have to know any cheat codes like you do here. So all we do then is we take R, point R, it's 1, 2, 3 units from our line of reflection. Therefore, to reflect it over this line, we just count 1, 2, 3 units on the opposite side and put R prime. We take point S. It is 1, 2, 3 units from our line of reflection. So we count 1, 2, 3 units on the opposite side and we put S prime. Then T. T is on the line of reflection. So all we do then is we just put T prime exactly where T is. If something is on the line of reflection, it doesn't reflect. There's nowhere to put it, so it just reflects on itself. Therefore, our new triangle, our image of triangle RST, after it's been reflected in the line y equals 5 or over the line y equals 5, is triangle R prime S prime T prime.
Jazzercise this exercise. Is it you try?
Okay, doing the same thing, except this time we have a rectangle. We have point L, which is at -1, 2. We have point M, which is at -5, 2. We have point N, which is at -5, 4. And we have point O, which is at -1, 4. So there is our rectangle LMNO, and we want to draw its reflection image in each line. So we're going to start with the x-axis. So where's the x-axis? That's here. And if we want to reflect each point over the x-axis, remember, you can just count 1, 2, and then 1, 2. So it's going to be here. Or you can make the y-coordinate just the opposite of whatever you see. So point L is at -1, 2. That means L prime is going to be at -1, -2. Point M is at -5, 2. So point M prime is going to be at -5, -2. Point N is at -5, 4, so N prime is going to be at -5, -4, and then point O is at -1, 4, so O prime is going to be at -1, -4. There is our rectangle, L prime, M prime, N prime, O prime. That is the image of rectangle LMNO after it's been reflected over the x-axis or in the x-axis. Now let's reflect it over the y-axis. So where's the y-axis? That's here again, since it's a vertical line. Remember, you could just count. Since point L is 1 unit away from the line of reflection, L prime is going to be 1 unit on the other side. Since M is 5 units away from the line of reflection, M prime is going to be 5 units on the other side, and so on. Or you could use the cheat code where you just take the x-coordinate for each point and make it the opposite of whatever it is. So instead of L being at -1, 2, L prime, after we reflect it over the y-axis, is going to be at +1, 2. Instead of M being at -5, 2, M prime, after we reflect it over the y-axis, is going to be at +5, 2. And then N, instead of being at -5, 4, is going to be at +5, 4. That's N prime. And then O, instead of being at -1, 4, O prime is going to be at 1, 4. We then draw that. There's our reflection of rectangle LMNO after it's been reflected over the y-axis. Lastly, we're going to reflect our rectangle over the line y equals x. Where's the line y equals x? There it is. It's just a line that cuts our coordinate plane in half diagonally, if you want to think about it like that. So we have a y-intercept of 0 and a slope of 1. Next, in order to reflect this rectangle over this line, we need to know the cheat code. We can't just count diagonally. It doesn't work like that. So instead, what we do is we take each coordinate and we flip the x and the y. So instead of L being at -1, 2, L prime is going to be at 2, -1. Instead of M being at -5, 2, M prime is going to be at 2, -5. Instead of N being at -5, 4, N prime is going to be at 4, -5. And instead of O being at -1, 4, O prime is going to be at 4, -1. There's our reflection of rectangle LMNO in the line or over the line y equals x. Now, example 3 says, given points RST, draw triangles RST and its reflection in the line y equals x. So let's see how this is going to be different. We know how to graph these points now. Point R is at 2, 5. Point S is going to be at 6, 3. And then point T is going to be at 3, 0. So that's right there. There is our triangle. So now we need to reflect it in the line or over the line y equals x. So where's that line? Remember, it's got a y-intercept of 0 and has a slope of 1. So it looks like that. Oh, I see what's different. Our line of reflection actually goes through our figure. So how is it different? It's not. You use the exact same cheat code. So instead of our R being at 2, 5, R prime, since when you're reflecting over the line y equals x, you just flip the x and the y coordinates, R prime is going to be at 5, 2. Instead of S being at 6, 3, S prime is going to be at 3, 6. And then T is at 3, 0, so T prime is going to be at 0, 3. We connect our green dots, and you see that after our triangle RST is reflected in the line or over the line y equals x, it looks something like this.
It's time for you to try.
So we're doing the same thing here. We want to plot these points. So point A is at -1, 2. Point B is at 1, 4. Point C is going to be at 5, 0. And D is going to be at 2, -3. Again, I'm going to reflect. This time it's going to be in the line x equals 3. So if I want to reflect this trapezoid, it looks like, in the line x equals 3, I need to figure out where's the line x equals 3. Well, if you recall, the line y equals 5, when we did that earlier, was a horizontal line. Anytime you have y equals a number, that's a horizontal line. Anytime you have x equals a number, that's a vertical line. So we go to the x-axis. Where does x x equal 3 right here. So we draw a vertical line that goes through x is equal to 3. This is all the points where x is equal to 3. Now all we have to do to reflect each of these points in the line x equals 3 or over the line x equals 3 is just count how far they are away from that given line of reflection. So we start with A. If A is 1, 2, 3, 4 units away from the line of reflection, we count 1, 2, 3, 4 units on the opposite side, and that should be A prime. B is going to be 1, 2 units away from our line of reflection, so B prime is going to be 1, 2 units on the opposite side. C is 1, 2 units from the line of reflection on this side, so then on the opposite side we go 2 units, 1, 2, and there is C prime. And then D is 1 unit away from the line of reflection on this side, so we go 1 unit on the opposite side, put D prime. We connect those dots, and that is the reflection of quadrilateral ABCD in the line or over the line x equals 3. Now example 4 says John and Lisa are tied going into the last hole of mini golf. John must hit the ball between the 2 posts in order to stay tied with Lisa. Where along the wall does John need to hit the ball so it makes it through the posts? So first step in a word problem, we're not scared. We can do this. Step 2, what does it want us to find? It says, where along the wall does John need to hit the ball so it makes it through the 2 posts? So here, to make it through the 2 posts, it would have to end up somewhere right here. So we want the ball to end up here. So where along this wall does John need to hit the ball? Well, here's what we know. When a ball is struck without spin against a wall, it bounces off the wall and travels in a ray that is the reflected image of the path of the ball as if it had gone through the wall. So all this is saying is that you take the ball wherever you want it to end up and you measure that distance from the wall, or our line of reflection in this case. We measure that same distance on the opposite side and we put our reflected ball. Then draw a line connecting John's ball to the reflected ball, and that should show you the spot on the wall where John must hit the ball in order for it to end up where we want it, through the 2 posts. So John must hit the wall at point P in order for the ball to end up through the 2 posts.